Okay, so let's go through the trial self 3, which is a 2021 A-level question. So we have a ball of mass 0.62 kg, right, being dropped from rest. So it then hits a horizontal surface and rebounds. So we are given the momentum time graph, right? So apparently for the very first part of the journey, so you can see that the momentum is increasing. So what is actually happening is that, for example, I have a ball right here. So initially, it doesn't have any momentum because they say at rest. So P is equal to 0. Then after some time, right, it will have a momentum just before hitting the ground. It has a momentum of 3.2. So P equal to 3.2. So you can see that momentum is actually not conserved due to the fact that if I just look at the ball as a system, the ball is actually being acted by a external force, which is known to be your weight or gravitational force. So for example, let's just say I look at the ball right here, right? So the ball is actually acted by a weight. So this thing is known to be your external force. And when we are talking about external force, the momentum will not be conserved. So that's why when you look at the momentum time graph, you'll see that the momentum is changing. Alright, okay, so at this part, just before you hit the ground, the momentum is 3.2. Then after that, right, you hit the ground. Of course, the hitting during the collision, the graph is not being shown. So the graph is something like this. So for example, I draw a line. So this blue color line will be the momentum change when the ball hit the ground. Okay, so after you hit the ground, this part is where you rebound, right? Okay, so with this, right, I will go on to part A. So part A, calculate the kinetic energy as it make contact with the surface. So kinetic energy of the ball, right? So we know that P is equal to mv. And of course, just before you hit the ground, the momentum itself is 3.2. So this 3.2, this will be around 0.62 kg. So the speed of the so-called ball, right, is let me just do a quick calculation. So it's about 5.161. So this is 5.161 meter per second. So we are asked to calculate kinetic energy, meaning that KE, right, is equal to half mv square. So you just need to sub in. So half 0.62, and this is 5.161 bracket square. Okay. So just need to calculate. So half bracket 0.62 times 5.161 square. So roughly the kinetic energy of your ball, right, just before you hit the ground is this. Okay, just round off 2 to 3 SF, so 8.26 joules like that, right? So this is 8.26 joules. So these 3 marks are quite simple to get the 3 marks. Okay, but I can actually show you one more formula that relates momentum directly to kinetic energy. But this one you'll learn more when you learn the quantum physics. So actually, there's one more formula that relates kinetic energy to your momentum, which is kinetic energy is equal to P square over 2m. So this one is actually quite a useful formula, because if you are given momentum, you can straight away calculate the kinetic energy if you know the mass of the so-called object. So you don't need to calculate the velocity, then after half mv square, because it's a bit long. So this one is quite a useful formula. Okay, so with this, right, I will move on to part B. Okay, part B, a 4-mark question. So determine the magnitude of the average force exerted by the ground on the ball when the ball is in contact with the surface. Of course, we are asked to show our working. Okay, so based on this question, right, definitely we must use something called the Newton's second law. So Newton's second law, right? Newton's second law is the change in momentum divided by the time in contact with the ground. But of course, just take note of one thing is that the F right here is not the normal, it's not the force that the ground exert on the ball. Yeah, it's actually known to be your resultant force. So always remember, for Newton's second law, is always the F is always the resultant force. But of course, if you did the trial self one, which is the the box, right, the 2 boxes hit each other, right, how come I can actually say that the force is the so-called the force that the box acts X on box Y. It's because it's a horizontal collision. So for example, right, when I talk about horizontal, okay, I don't draw the ground. Okay, I talk about horizontal collision is that, okay, for this, right, this is X, this is Y. So this will be the so-called resultant force. But if we are talking about vertical collision, so for example, let's just say we are talking about the ball hitting the ground. So the resultant force, I cannot just say that the resultant force is this thing. Because we must also take into account of the weight of the ball. Then things will be a bit different already. Alright. So, okay, let's do the calculation. So apparently, we determine what is the resultant force first. So the resultant force is equal to the change in momentum divided by the change in time. Right? Okay, so let me just go back to the so-called graph. Okay, so the graph, right, so let me just calculate what is the delta P first. Okay, so at this particular point, just before you hit the ground, the P, or the initial momentum, let me just write down initial momentum, is roughly 3.2 Newton second or kg meter per second, up to you lah. Which one you like. So at this particular point, the momentum will be roughly negative 1.8. So you can see that, okay, now you've put down momentum. Okay, so the change in momentum will be final momentum minus initial momentum. So I just get the so-called the magnitude. So of course, negative 1.8 minus 3.2. So this will actually give me negative 5. Then I get the magnitude, means that the delta P is equal to 5. Okay, with this, right, I will need to determine what is the time in contact with the ground. So this is where you need to look at the x-axis. So for example, right, if I zoom in, so you when you hit the ground, you are actually at a time of roughly, okay, this is 0.5, this will be 0.53 seconds. Okay, then after you hit the ground, you want to leave the ground already, right? So at this particular point, which is the blue color one, right? So this will be roughly 0.2468 seconds. So the time in contact, the delta T, right, will be right here, which is roughly 0. Okay, I put a second first. Okay, 0.15 seconds. So that will be the delta T that we are talking about. Right, so you want to calculate the resultant force, is delta P divided by delta T. So delta P is 5, delta T 0.15. So the so-called the resultant force, right, 5 divided by 0.15. So roughly is about 33.3 Newton. But of course, this is not the answer, because remember, this is your new resultant force. So when we are talking about vertical force, things are a bit different already. Okay, so let's take a look at, write down this first. Okay, let's take a look at the so-called free body diagram. Okay, so when you hit the ground, of course, there's a so-called contact force, which is the force by the ground acting on the ball. But not just that, there is a weight component, right? So this is the mass, this is the so-called G field of the Earth, 9.81. So when you multiply, right, you will realize that, hey, my weight, this is your so-called weight, right, is about 6.0822. Okay, with this, right, I can actually calculate. So what is resultant force? Okay, resultant force very simple. Definitely, this thing will be greater than the weight, because you want to rebound, right? In order to rebound, this force, let me just draw a longer force. Okay, this force right here must be greater than the weight. If not, you can't really rebound. Okay, so resultant force is this thing, the first force, right, minus away the second force. So F is equal to first minus second. So what is the resultant force? Resultant force 33.3, right? Then I want to determine what is the force by ground. So I know that, my weight is 6.0822. Then just need to solve. So for example, you manipulate a bit, right? So this whole thing right here, you move over. So 33.3, right, is equal to force by ground minus 6.0822. So force by ground is equal to 39.3822, or you can just put it as 39.4 Newton. Yeah, so that is how we actually solve this question. So the answer for this, right, is 39.4. So this one is a bit different because F, remember, for Newton's second law, F equal to delta P delta T. So this thing must be the resultant force. Especially this, especially important if we are talking about the vertical. Let's just say the ball is colliding the thing vertically. But if we are talking about horizontal collision, for example, I have a wall, right? Then after that, I hit the wall horizontally. So initially, I have some momentum. I don't know what momentum, like Pi. Then I rebound with a final momentum. So this one, you can simply just use delta P delta T. You can treat the force, the so-called the F, to be the force that the ball exerts on the wall. Because there's no weight component to take note of, right? Okay. With this, right, I will move on to the very last part. Okay, the very last part is actually quite a difficult question. So they say that, the ball loses the same percentage of KE, right, every time I rebound. So determine the number of time I rebound such that now my total energy will decrease to less than 5% of the initial energy. And of course, I need to show my working. Okay, so just before I hit the ground, right, I know that my kinetic energy is, I know that my speed, right, is 5.16 lah. Then after I use half mv square, my kinetic energy is roughly 8.257. Okay, let me double check something. Okay, yeah, about 8.26 like that. So 8.26, that will be my initial kinetic energy. After I hit the ground, my kinetic energy is 2.61 joules like that, right? Yeah, so how do I actually determine the kinetic energy after I hit the ground, right? You need to look at this part. So you need to look at this momentum here. Then you just need to calculate your kinetic energy. So after determining your kinetic energy, right, you realize that, I only have after my first bounce, right, I only have 2.6071 joules of my energy left. So I need to determine what is the percentage of energy that's being left, right? So you just need to use 2.6071 divided by 8.257. So this is the fraction of energy left for every bound. So just do a quick one. 2.6071 divided by 8.257. So what you actually get is 0.31, about 0.316 of the initial energy. So how do I actually do? Very simple. So what I need to do now, because they say the energy loss, the percentage energy loss is always the same, right? So I can actually put like that. So for example, right, okay, so this is 0.316 bracket to the power of n. N means the number of bounces. So you multiply by the so-called kinetic energy. So the initial kinetic energy, maybe I put E lah. So it's equal to, so they say I want to be less than 5%, right? Meaning is 5% I express in terms of fraction is roughly 0.05 E. So of course you can see, right, the E can be cancelled away, but if you are not comfortable with cancelling the E away, you can just sub in. So for example, my E, right, initial kinetic energy is 8.257. Likewise, this one is 8.257. So for me, I try to do my cancellation. So this one you cancel. So what you need to actually solve is actually this one. So to the power of n is equal to 0.05. So you want to solve for n, right? You just need to, for me, I log both sides. So LG 0.316n equal to LG 0.05. Then you can apply the power law. So for example, the n, right, you bring it down. So become n LG 0.316 equal to LG 0.05. Then bring this whole thing to the right hand side. So what you actually get, right, is, let's do a very quick calculation. 316. So it's roughly, the n is 2.6 like that. But of course you must round it up. Because 2.6, there's no such thing called 2.6 bounds, right? So it's either 2 bound or the third bound or the fourth bound, right? It's a whole number. So at the second bounce, right, your energy is still more than 5% of the initial kinetic energy. So only at the 2.6, so-called the 2.6 bounce, right, your energy will be equal to 5% of the initial kinetic energy. So of course, I need to round up to 3 bounces. So the number of bounces that is required, right, is roughly 3 bounces. So for this part, I believe the difficult one is to actually determine this. So it's about 0.316 n, right, times E equal to 0.05 E. No. So that is how we actually do this question.